Alright, so for this video, we're going over the homework assignment in 8.3, the first one. Given a list of integers, use a vector and return the mean, median, and mode of the list. And I already have an editor here. I copied over the sentence just so we have it here. And I have some notes for myself. I'll let you know when we need those, so we can go over them then. Just things I had to look up. So let's start. Mean is the average, right? And as averages goes, it's the sum of the items that you have and then divided by the number of items that you use to create that sum. So for example, if we have, let's say, let example equal vector 1, 2, 3, 4, 5. This would be the sum of all of these. So 1, 2, 3, 4, 5, all summed, which is 6 plus 3, 6, 12, 15. 15 divided by 5, because there are 5 items in here. 1, 2, 3, 4, 5 should give us 3. And let's write a function for that. Mean, call it a list. We're going to take in a vector, a reference to a vector, because we don't need to change anything within it, so it can be a reference to a vector. We have the type of the vector, or the elements in the vector, the type of the elements in the vector, which is I32. Yeah, so that has to be marked. And we're going to return, I'm going to say a float possibly, so F32. And yeah. So we need to take the sum of everything in it, of this vector, which we called list. So we create a mutable variable called sum. Set that equal to 0. And then we sum everything together. So for, let's call it num in list, right? And if we do sum plus equal num. And because we're returning a float and we want to do division, we should make sum, cast it to a F32, and then divide it by the number of elements within this vector. So list.length, I believe. And this also has to be the same type. Operations have to be matched in type. So F32 divided by F32. And this should theoretically give us the average. So let's test this out. I don't like this indentation here. Boop, boop. I think it's 4. Yeah. Print, new line. I'll call it mean. And do mean, and then pass in our example, which is going to be a pointer reference. Let that run. Mean 3, which we said it should be. So one thing to note here is we should probably throw in some other example to see if this breaks. You know, test out the functionality of this for a bit. Make it another 5. See what that gives us. That gives us this point 3 repeating. Alright, so we can have floats. So what happens if this is empty? What does that do? Ooh, run. Not a number. Well, I'm not sure if I like that, but I mean, it's something. If it is empty, then it's divisible. We're dividing by 0, and that's why it's not a number. I don't like that interface. Maybe we should just check to see if it's empty and then return 0. I mean, I guess that's the smallest average. Unless you're using negative numbers. Everything should probably be positive. Ugh. We're going to ignore that. We're going to check to see if it's empty and then do something. Return 0. That sounds reasonable to me. So list dot, look at this method list. I see an is empty, returns a boolean. So if it is empty, let's just return, we could say return 0, but we can just return sum. Yeah, if I move this, cut, I've already defined sum, do the check to see if it's empty here, return sum, and the sum is currently 0 at that point in time. I mean, does it have to have? Error, integer, oh yeah, that's right, as F32. Yeah, okay, so now we have a empty list, right? We check to see if the list is empty, right here, and we return the sum as is, 0. That seems to work for me. So moving on to the next one. The next one is median. And the thing about median, let's look at this up. Median has 2 different cases. So based here on the right, median is seemingly the middle value in the list or vector or array, however you want to define those containers. However, the length of said vector, in our case vector, can be even or odd. If it is odd, in this first example, we have 1, 2, 3, 4, 5, 6, 7 elements. Then it is the 4th element that is the middle one. So there's 3 on this side, 3 on this side. This makes this the middle. Return 6. That sounds fine. However, if we have 8 elements, 1, 2, 3, 4, 5, 6, 7, 8, then we now have 2 middles, which is 4 and 5. We add the 2 middles together, and then we divide by 2, and that will give us our median. So 1, we can take away that our median can be a float, like in this example. Another takeaway that we have is that we have 2 different cases. We have even and we have odd. So it looks like we have to figure out how to distinguish if a number is even or odd. Going back to our editor. So typically, in other programming language, when I want to do something, check to see if something is even or odd, I use modular arithmetic. You check to see if something mod 2 is 0 or 1. Modular arithmetic is you divide the number and then you look at the remainder, right? So if you divide something by 2, the remainder is either going to be 0 or 1. If it is 0, we know that it's divisible by 2. If it is 1, then you know that it is not divisible by 2, which makes it odd. However, from my understanding, Rust does not have modular operator, so we're going to have to do it ourselves. Given that modular arithmetic is based on division, we can use division to figure out what the remainder would be. And given that division can be replicated via subtraction, we can just use subtraction over and over and over again. As in, we have our number, we minus 2, and then we keep doing that until our number is now less than 2. And if our number is less than 2, then, well, given that the number was positive to begin with, then our number is now going to be 0 or 1. So let me write that out so you guys can see it, but it's just division via subtraction. So is even, right? Is even. We're going to take in a number, call it I32, and then we're going to return a Boolean. Put a space there. Alright, so I'm going to copy this number over just because I'm going to do some things with it. So let mutable n equal number, right? And this is where I looked up the loops. I would like to do, while a condition is true, keep doing this operation. And I had to look that up. So I have the link right here. Link going over while loops. Control copy. I searched for it on DuckDuckGo. I use DuckDuckGo. And it brought me to this link, but so here's the link. I could have copied and pasted it in. I still will just for clarity. Is doc.rustlang.org books loops.html. So it's just one of the other Rust books. And here we have a loop, an infinite loop right here. We have our while loop, which is the one I want to use. And then we have the for loop, which we've used before. So for the while loop, we have while, and then we have a condition. And then we keep doing this until this condition is no longer true. So once this condition becomes false, we exit the loop. And what we want to do is we want to take our number minus 2 over and over and over again until our number is less than 2. Because if it's less than 2, then it should be 0 or 1, given that it was an integer. So let's try to write that out. While n is greater than or equal to 2. This is the condition. So n is still too big. What we want to do, I could probably call it remainder. It doesn't have to be n. Yeah, remainder sounds better. Call it remainder. That sounds much nicer. Remainder. While the remainder is greater than or equal to 2, remainder minus 2. Over and over and over again, right? Now, if the remainder is equal to 0, then we return true. If it is not, then we return false. So right here, we can just say false. And let's test this out real quick to see if it works. Kind of don't like the spacing. That there, I guess that's fine. Go back to our main function. We call this isEven, and we can pass in some numbers. Let's say 10. See what happens. We have an error. Vector type T. A vector needs stuff in it, but it's not being used right now. So we called it mean isEven for clarity. Is 10 even? It says 10 is not even. False. So now it looks like we did something wrong. Let's go back to our isEven function. If I want to debug this, I'm going to put a print statement here just to see what's going on. And look at remainder. Because you may not have looped enough. And it says 10 is even false. So remainder, while remainder is less than or equal to, we did this backwards. So what we want is the remainder to be less than or equal to 2. However, it starts off at 10. So while remainder is greater than or equal to 2, so if remainder is greater than or equal to 2, we want to subtract 2 from it. So we just need to flip that operator. And now we come back, we get that remainder is 0 and isEven is true. All right. So let's go to 11. We get the remainder is 1 and isEven is false. So where this kind of breaks down is what happens if the number is negative. In our case, it won't be, but theoretically speaking. Negative 10, false. So what happened here is that we had a negative number, and our negative number already satisfies this condition. Because it satisfies this condition, it never goes to 0 or 1. It just stays negative. Negative is well past 0 or 1. It's always less than 2. So we should change things to an absolute value. In order to change something to an absolute value, let's look at the method list here. I'm not seeing anything that says absolute value. When I first looked, I didn't see it. This is my second or third time looking, I still don't see it. However, when let me search for it and looked it up, I saw you can just do ABS on I32 and that gives you the absolute value. And this, I think this is the link to the documentation. Oh, well, results for absolute value. There's a lot of things here. And I32 is right there. It looks like all numbers have it. but it is good to note that in the editor, we're not going to see all possible methods that can be called. And as such, if you believe a method should be there, or you're not seeing it and you want to verify that it truly doesn't exist, search for it, look it up, just double check everything, because this list is not complete. So do absolute value, right? Change that to absolute value. We still have our negative 11. Oh, do we have negative 10 or 11 in here? Negative 10. And now we get that negative 10 is even. Cool. That seemingly works. So what did we do just now? We checked to see something is even. And we did that because median requires the middle position, which may be 2 or 1, based on whether or not the vector is a length of an even number or an odd number. So let's start writing out median. I think we have enough. Function median. Ooh, that's something to note. Median has to be sorted. Because it has to be sorted, there's a possibility that the list we get is not sorted. So before we write median, we should probably write a function to check to see if something is sorted. This is common in other languages, like a method that you can call to check to see if something is sorted. When I looked it up for Rust, I don't believe it existed, but let's just double check. I saw something, I just don't remember what it was. So T, control copy, or click, go to it. This is the big list, this is the small list. T, this is the big list. Control find, sorted. Sort, binary search. I can just look at the method list on the left side. Let me just scroll through here. Split, traits. I believe something is here that says sorted, is sorted. Here, so they do have an is sorted Boolean. Is sorted method that returns a Boolean. However, this is nightly only experimental API. So as of right now, I cannot use this, but you'll be able to use it in the future. As such, we have to write our own function to check to see if something is sorted. Not all that difficult, but you know, it's something we have to do. So before we write median, we have to figure out if something is sorted. So is sorted, right? And we're going to take in a vector. So call it list, reference to a vector, because we just need to look at the items. We don't need to do anything with it. Everything we're using here is I32, and then we're returning a Boolean. So if we want to check to see if something is sorted, what that means is that the element in this position, let's say position 0, is always going to be less than or equal to the element in position 1. And the same thing can be said for position 1 and 2, 2 and 3, 3 and 4. So as you iterate over the index of the vector, going from 1, 2, 3, 4, 5, 6, 7, 8, every element in that block is either going to be less than or equal to the one coming up next. So to write that out, let's check. What's the best way to writing this out? So we have some cases that come into play. What about if the list is empty? If the list is empty, is it sorted? Technically speaking, true. If the list has one element, is it sorted? Technically speaking, true. If the list has 2 elements, then it can be out of sorts. You can have 2, 1, which is not sorted. It'd be 1, 2. So let's create our result variable. We'll make it mutable result. Let's set it equal to true by default. Equal to true, right? And at the end of this, return a result. as we said earlier, we know that if a list is empty, it is sorted because there's nothing to sort. And if the list has one element, then it's by definition sorted because you can't be less than anything else. So let's write those two cases quickly. If the list.length is equal to 0, or, I think this is how you do or? I'm not sure, I have to double check that. List.length is equal to 1. Oh, that seems right. Return result, which is by default true. If the list has more than one element, meaning the list has 2 or more elements, then we can do things like put the first element in a variable and then check the second element as we go along, things like that. Let's write that out. So create an index, right? Let mutable index equal 1 while index is less than the list.length minus 1. We can check to see if list at index minus 1 is less than or equal to list at index, right? So this condition is the opposite. This is what we want to be true. For it to be false, the index prior has to be greater than the following index. So if index minus 1 is greater than list at index, we now know that our result is false, and we can break from the loop and return false. Hopefully this works. Let's check it out. Come down here, do a is sorted, and pass in our example. Give it some elements, 1, 2, 3, 4, 5. Pointer to example. It seemingly compiled. Wait. Oh, is sorted. Hold on. Why don't I see a value? Is the loop still going? This is an infinite loop. Ah, I see what we didn't do here. This is an infinite loop. I said close that. What we forgot to do is increment the index. So yeah, index plus equal 1. And what this does is make sure that our index goes up and we're moving across the vector. So try that again. I still have it written as is even. So this now is sorted. And it says that is true. So 1, 2, 3, 4, 5 is sorted. So let's put a 1 at the end and see if it's still sorted. It says it's still sorted, meaning that we did not go to the end, seemingly. So let's take away that minus 1. Is sorted false. All right, good thing we checked. So let's do another example. Empty, true, 1 element 5, true, 1 5, true, 6 1 5, false, and 6 7 10. True. So our is sorted, something to check to see if something is sorted, seemingly works fine. Now I think we have enough information to write the median. So let's do that here, right? Function median, we'll call it a list vector. So one thing to note about median is that this works on sorted lists. So if something is not sorted, we're going to have to sort it. And if you were to sort a vector, seemingly you're moving the elements in different boxes. You're taking, maybe if it's, let's say, let me type it here. If you have like a vector of 1, 3, 1, 4, 2, then you're going to move the 4 and 2. You're going to switch their places, right? Make it 2 and 4. However, when doing that, you're moving memory around. And because you're moving memory around, we need to have ownership of the vector. So come down here. That's why we're not using a pointer reference for this vector. And this is going to return a float 32 because it can be a float. So now that we have our vector in, we need to check to see if the length is, we need to check to see if the length is even or odd, and we definitely need to check to see if it is already sorted. So let's do the sorted one first. Do I have a note over that? I do not. So I remember how I went about doing it. We're here, right? This is the page that we looked at earlier for vectors, and we looked up methods for is sorted. So if you keep, if we just look for sort, right? And keep going, I think we find one. We have a sort here. What this says is, this is sort stable. It does not reorder equal elements, and it is big O of n log n, worst case scenario. When applicable, unstable sorting is preferred because it is generally faster than stable sorting and does not allocate auxiliary memory. See sort unstable. And sort unstable takes a mutable reference, mutable, self, and this is seemingly what we want. Sorts the slice but may not preserve the order of equal elements. Okay, and here's an example of using it. We have a mutable vector, and then we just call sort unstable. So come back to our editor. Where's here our median? We can say if is sorted, pass in our vector, which we called list, is equal to false. Then we can do, it had to be a mutable reference, right? Mutable. And that our is sorted takes a pointer reference. I believe that should work. And now we do list dot sort unstable. In order to check to see if this worked, we can just print something out here. I think checking is advisable. So one thing to note, I forget the syntax, but we have to do debug to print out a list. I think it's like colon and question mark. And we put out list, and we can just return 0 as F32 for now. Just so we can call this. Should have a typo in word. Median. Did I type it? Yeah, I did misspell it. So we're doing median now, so we can change that. Median. This is now mutable, and this is no longer a reference. And we just want to make sure it is sorted. That was already sorted. Let's unsort it. Put 11 here. And it gets sorted. Cool, so the sorting is working. Next, we need to know if it is odd or even, right? Let's get rid of this. So we can take the length and figure out if it's odd or even. Is even? Make it a variable. Is even. It's going to be a Boolean. Is even. Oh, we have a variable and our function name. That's really bad. Yeah, I don't want to do it that way. Let me just do it in an if statement. That would look really ugly. If is even, we'll take in our list dot length, and we have our else statement, which means it is odd. So go back to the Wikipedia article real quick just to figure it out. If it is even, then we want the middle two elements. If it is odd, we want the middle element. And to figure out the middle element, we can just do inner division, I think. That should probably work. So let's do the odd case first. Actually, I can probably figure out the middle. Let middle equal the list dot length divided by 2, and then here we want our result. So let's define our result at the top. Let mutable result equal, I don't know, 0 for now. -1. And we can say that our result is equal to the list of the middle as usize, because it's usize. And down here we can just return our result. We return our result. Ooh, our result has to be F32, doesn't it? Yeah. I'm pretty sure I could just define. Can I just say it's like F32? I don't know how to define the type without giving it a value. That's probably something I should look up later on in life, but I don't think I need it right now. As F32. And this has to be converted because now you're the wrong type as F32. Not exactly sure why that's angry, but we'll find out soon enough. Here the result will be equal to this portion. Control copy, paste, plus, well, technically speaking, we can do the addition first, right? It's not until we do division that we need to convert it to a different type. List, middle, and I think we need to -1 from it, actually. I'm just call this middle 2. Middle 2 is equal to middle -1 middle 2 as usize. I didn't want to write all of that in there. So we're going to add those two together. Maybe if I put them in parentheses, that'll make an operation. As F32 divided by 2 as F32. So we still have this one red line thing here, but let's see how this goes. Ooh. Length is the wrong type. They expected I-32. Middle 2. Did you mean middle? Because I didn't define this properly. And they already set it as U size. That's interesting. Oh, because they made middle U size. I didn't even know that. So if middle's already U size, then I don't need to convert it here. And I don't need to convert it here either. In fact, I probably don't even need middle 2. I can just minus 1 there, as is. And I got a number now, 8.5. And I have this 0. Where's the 0 coming from? Remainder. No longer needed. And is that true? I have no idea because these numbers are sort of big. Well, actually, 6, 7, 10. I guess that's 17 divided by 2? Yeah, 17 divided by 2 is 8.5. Because when sorted, so yeah, that's right. That's our even case, and then we have our odd case, which is like 1, 2, 3, 2. And then if we make this a 4, 2.5, because 2 plus 3 is 5, divided by 2 is 2.5. So we have median. Median works. Oh, let's look at the other cases. What happens if this is empty? We get an error. Index out of bounds. I don't like runtime errors. We can probably just check and return something. Technically speaking, we should handle errors properly, at least in my opinion, but in terms of the Rust book, we haven't gotten to the chapter that discuss errors yet. That is the next chapter. So as of right now, I'm just going to return something, and I'm just going to return 0 because that seems sufficient. So if the list is empty, return results. Run this again. Now we're returning 0. So if the list is not empty, let's say the list has 1. I keep saying list, vector. The vector has 1. Then we return 1. Technically speaking, 1 is the middle element. That makes sense. And if we have 2 elements in there, 1.5, that sounds correct. Alright, so median is done. So let's move on to mode. And what is mode again? The value that occurs most often. A hash map will be helpful here. That is their hint. And according to the hint, and according to this chapter, there's 8.3 dealt with hash maps, right? And they did an example right here that dealt with counting and creating a counter map. So we could probably just use this for the most part. So we need to import hash map, create a new map, and then do the dot entry or insert, which if it doesn't exist in the map, it will insert it as 0, and then you have a dereference counter to 1, and then you can increment up. Yeah, I think we can just do that. They did split white space. We're not dealing with white space per se, but it's more or less the same thing. Let's write that here. Ooh, import it first. You want hash maps. Use standard library dot collections dot hash map. Come down here. Function. Call it mode. Take in we'll call it a list, and it's going to be vector reference I-32 and we're returning. Wait, what are we returning? Oh, the item that it occurs most often. Given that our vector is all I32, we can just return I32. So in their example, they created a map. So let's say let mutable map equal hasmap.new. And then for, what did they do? Let's do item. Yeah. Call it number. We're dealing with numbers. For number in list, they had a counter. Wait, did they call it a mutable counter? Let me just double check that. Let count equal, and then count plus 1. Okay, I'll try that. Let count equal map dot entry. We're entering the number, or insert 0 for the value. And we have a dereference count plus equal 1, right? And then we need to find out which one of these entries occurs most often or has the highest number. So we can say, I'm gonna put our result here. Let mutable result equals I32. We can say 0 for now. Call it -1. Pretty arbitrary. Now we can iterate over the hash map. So how do we do that again? For, it's probably a tuple. Key value in map dot iter. Yeah. Ooh, that's a reference. That looks weird, but I guess that's correct. Oh no, I should definitely put this closer to the map because it's more than just a result. So we need current max, right? Let mutable current max. We need to iterate over it and figure out what our current max is. And then if we see anything greater than our current max, we need to reset the result. Current max, say that's equal to 0. Actually, -99999. It doesn't. It should be really low. Let our mutable result. Result equal to. I guess it could be equal to current max. I don't see no harm in that. Then if the key is greater than current max, we want to say current max is equal to the key, and say that the result is equal to the value. Oh no, current max key is the number. We need the value comparison. If the value, how many times it's been seen, is greater than current max, and the value can only be 0 or higher, so this can just be -1. Then we set the current max equal to the value, and the result equal to the key. And then we continue on, and then return result, right? We have some red lines, so it looks like things are going to error out, but let's see what happens. Key. Expected integral variable found I reference. Key reference. Do you have like a dot copy? Let's do a clone. Does that work? Yeah, I'm in the middle of something.
Oh, I was just wondering if you were in a video.
I am.
Okay. I go away.
Ah.
Janice just found out the kitten.
Alright, see if that worked. Well, let's look at this error again. Maybe we did something wrong. We have our value, which is I32, and we have our key, which is an I32 reference, which is kind of annoying. What about if we don't make that a reference? Ooh, okay, that might make things easier. If it is not a reference to our list. A reference to our vector. Run that again. Current max. Consider dereferencing the borrowed variable. So dereferencing star. And current max. Expected reference found. Consider borrowing current max. This is a lot of borrowing. Mutable, current max, value. Oh, because value is dereferenced here. I think I can just dereference that and check the values against each other. Yeah, that worked. Okay, so what we seemingly ended up doing is following the different error messages we got to dereference things. So we're checking to see if the value 1, I'm really confused. How do we get 1.5 and 2? Oh, we're still looking at median. This isn't even mode yet. Mode. Put mode in here. Mode. And that takes an example. If it's that, mode 1. 2, 4, 1, 1, 1. Mode 1, 2, 2, 3, 3, 3, 3. Just to make sure it's doing what we think it's doing. Cool. So we have our mode. We're calling it, we're passing in our vector. We're passing ownership to it. We have our vector, comes in, we create our hash map. We then fill a hash map with the variables, the items in the list. We have our entry. If it does not exist in the map, we make the value of it 0. We dereference that counter, and we just increment the value of that. Increment the value for that key value pair in the hash map. So what you can see here, let's just print that out so you can see what it looks like. Print. I think we can do the debug syntax and just print out our map, right? Ooh, I think if we do the hashtag, it goes down. Hashtag, yeah. Cool. So we see that there are 7 3s, 4 1s, 1 4, and 2 2s. That's what we have here. And this is what we've created by just writing this. So it comes through here. It sees a 3 in the list. Is 3 in the map? If it is, use that value as the count. If it's not in the map, insert 0 as the value. And then after we do that, we increment the value by 1. And we do that over and over and over again with all of these numbers. And that's how we get our map filled. After that, we have to iterate over the map and try to figure out which one is the most highest occurring value in the map. And we do that by comparing the values of each key pair. So let's say this is a different order. Let's say we're coming in with 2s first, right? We iterate over. You see the key 2 and the value 2. Well, that's greater than -1. So that is our current max. Then we see, let's say 4. 4 key value 1. That is less than our current max, which is 2. So we do nothing. Go on to the next one. We see the key 1, value 4. The value 4 is greater than our current max, which is 2. So we say this is our new current max, and every time we see a current max, we give it a result. I'm not sure if I have to clone this. I think I can get rid of that. And it gave me a red line. I'm going to put that back in. And finally, coming down here, we see the key 3 and the value 7, which is greater than our current max. So we go through this if statement, and then we clone that over, make that our result. We come out of this loop, we have our result, and we return it. And that gives us our mode, which is the item that you see most in the vector. And let's see what happens if you have 0 elements. If it's empty, what happens? -1, that's what I put in there. And if it is not empty, save only has 1 element. Returns 1. Makes sense. So as we get rid of this print statement, and yeah, we have completed it. We have written a function for average, median, and mode. And with that, our homework assignment is done. Thank you for watching the video. I hope it was useful, hope it was entertaining. Peace.